So thanks a lot. So you already saw something about serverless machine learning, something special, the chatbot thing. And I'm going to be a little bit more general. So this is my name. This is the link to the slides. And this is the conference. Anyway, so first part, we have two parts. So the first part is we use a service that already exists. That's the easier part, obviously. And what we're going to do, to have an example here, is that we are trying to understand which of our emails are in a good mood. I mean, people send it in a good mood, and which ones are in a bad mood. And as a short disclaimer, I have to agree with the lady that did the previous, or one of the previous talks. It isn't perfect, so the sentiment analysis API isn't perfect, but it does work. So the one that I'm using for this demo is the Google Cloud Natural Language API. It works like this. You give it a document, something that you prepared it, and then you give it to it, and then it gives you an estimation, is it good or bad? And if I give it Oliver as a great person, it gets the impression that's pretty good, right? 0.5, but it could be go up to 1. So 1 is like really good. I'm not quite sure what I have to do to make it like the perfect thing, but this is not perfect, but good enough. And you can just use it. So you can just go there, you have a free quota, but you have to pay once you reach the end of that quota. So to actually show you this in real life, I used a workflow orchestration tool called Ultradocs, and it takes away all the needs for the authentication and fiddling with the APIs. So first, how would that look like? So I prepared a screencast here because I'm afraid of live demos. So screencast. So, wait. So in this case, I'm choosing from a Gmail inbox, I'm choosing a label, sentiment, created for the demo. I'm telling it, show me the last 10 days, and then show me 5 messages. And then I submit that, and then what it does, it sends all these emails to the sentiment analysis API and gives me the mood. And it doesn't always work, but it's pretty good. And I also have this good email, which is very positive. And I also get a real email, which sums that up. So we built that to make it a little bit more like lively. And then I have this "you're a great person" thing. You can click on it, and you see it's actually it's pretty good. So I did all I could, but still not perfect. So the idea is, I mean, for this use case would be, it's pretty simple, but the idea would be, you get a lot of emails, maybe you have to do maybe you have a small business, and you want to react to emails depending on the sentiment. So maybe you want to react to good emails because you have a bad day and you just want to read good emails. Or you want to react to bad emails because that might be the person who is angry at you and you have to react fast. That's pretty simple, and the core of it is the sentiment analysis stuff. And I'm just briefly showing you in a 1-minute video how this would look like with this thing. And it's not important that this is Ultradocs. It could be something else. It could be if this, then that. It could be Zapier or something. It consists of a number of steps that you execute. And then at a certain point, you need to call the Google APIs. And this is typically you have to do auth, then you have to provide some scopes. But you can just click it together like this. And what it does, it looks for it finds the Swagger definition files, and then once you do this, it gives you blocks like this, and you can just do sentiment analysis. So this is not specific to this tool, but it's in the Swagger definition of the Google API, which is pretty nice. And then you say how you want to execute it. You have to give it authentication scopes. You have to do that, because maybe you don't want to do it using your account. Whatever. That's typically pretty tricky to do it by hand, so we just use this tool to make it a little bit easier. So I'm granting authentication scopes here to make the call go through. And then these are the outputs from that service, and this is the input, and this is all like Swagger file generated, so nothing too fancy. And then we link it into that workflow of several steps, and every step that's called in here, it's a serverless step. So like getting the email from Gmail, and then putting that data to the sentiment analysis. And there you go. If you started, you get the application you just saw. And this is, so the idea why I show this is that it's pretty simple to use these services to get something really powerful, right? I mean, something like this, in a bigger company, you would need like months of work to do that. More APIs. I just chose this one. There are a lot of serverless APIs that you can just trigger and get some good results. And then you use some sort of workflow to put it in a larger context, and then you get amazing stuff. And this is obviously face detection or recognition. These the same two persons, and this thing says yes. And you just can call that API. It's again, at a certain point, you have to pay for all these services. But just to get started, it's for free. So, first part. Now, second part. Maybe this is more interesting. I'm not quite sure. So, in the second part, what if the stuff that you are trying to do, it's just not available? It might not be available because the stuff that you want to do, it's based on your own data, maybe your customer data. And I made up an example. It's not a real example. And the example goes like this. Just imagine you work in a car insurance business, and you have customer data. It looks like this. You have the age of the people, like the people you insure, and you have the max speed of the car that they're trying to insure. And these dark ones are green, which means they're good customers. They don't have any issues. They don't have accidents. Red spots, they tell you that's probably a problematic customer, a lot of accidents, and yellow ones, they tell you somewhere in the middle, a few. And this is made up data, but if you consider this might not be car insurance, but other metrics of your customers. And what you want to do is you try to predict how would a new customer do in that scheme. And that might be me. I'm 47. I don't own a car, but the previous car I owned, it had top speed 160. So, with all this data, is it possible to train a machine and then deploy it serverless so that you could make a prediction? And the answer obviously is yes. Well, otherwise I wouldn't do this talk. But what I'm showing is how you do this with the very famous framework TensorFlow. And it's pretty simple. So I did this in Python, but you could do this, I think you could even do this in Java, maybe something else. So what you do, you say you have two inputs, going back, one input, two inputs, done. And then you define a neural network, which is 3 layers, and at the end you have a predictive layer. And if you ask me, well, how do I configure this? I will tell you, no one knows, like really no one. And whatever some people claim they know, but what you really do is just you fiddle around and you try things out, and then you hope it works. And it sounds like, well, trust me, that's the way you do it. Anyway. And this is called deep learning, because we have 3 neural network layers, and this is like the fancy stuff. Good. I did this, and I will share the notebook where I did this with you, so I share the code. You can check on that. I took a few more data points, as you can see. And then what I did, I trained the network with the data, put it in. It's pretty simple. It's pretty straightforward. And then the background colors that you see, those are the predictions of the network. So it tells us, for this data point here, the prediction will be green. And for this, red. And you see some of the dots are wrong. This one, this one, this one. But most of the dots are right. So that means the predictive power of this thing that I really trained is 77%, which is a lot. Guessing would be 33%. I did this by programming it by hand, 40%. I did this statistic model, which is really complicated, 50%. So this thing is pretty good. So now you have that, but now this is, up to this point, it's just toy. It's just play stuff. How do you bring it into production? So fortunately, there's this thing here, the Google Cloud ML engine, and it accepts TensorFlow models. And I have a TensorFlow model, which is a good point. So this is really actual code. You copy it into a bucket, which is like storage on the Google Cloud. And then you fiddle around a little bit with this interface, or you also execute some commands on the command line, and then you have a model, and then you have a version of the model, and then it is deployed. Done. So it's live, it's up, and then you see some statistics, you see are there errors or not. This is really small, but there are no errors here, and the single prediction. So now it's live. The question might be, how do you call it? I mean, how do you use it? So you have to provide it with inputs, obviously. And this all works, so it's real stuff, it's really deployed. And the inputs are like 460, top speed, I'm 47, and I drive 10,000 kilometers. So the model is even a little bit more complex. You call it, this thing does all the authentication stuff in the background, but in the end, it's more or less like a normal HTTP call. So you call it, you say you want to predict, this is the name of the model, this is the version, so it versions, obviously, and then you give the data, and then the result, which is pretty interesting. So typically, these models, they don't tell you it's this or that, so they give you percentages, like likelihoods. So that it says, the first category, like red, you're a bad customer, the likelihood of this is 0.3%, like extremely unlikely. And then the yellow, somewhere in the middle customer, 6% or 6.5%, and then this one is 93, so it's pretty sure I'm going to be a good customer. And this is like a very, very standard, like format for a result. So if you train a different model, you probably get a result like this, and you can decide which percentage is high enough for you to actually use that result. And if it's like 20, 30, 50, then you might want to just discard it. Okay, 2 minutes left. Just considering if I actually click on the notebook, I guess I will. So as I promised, all this stuff is real, and I published that notebook. The data is made up. I can't show you real data for obvious reasons, so I generated that data. I'm showing you the notebook here, because I'm brave today. That might have been a bad, no, it was a good idea. Oh, okay. Okay. So it seems to work okay. Oops. Unless that I'm missing my cursor here, but I can scroll with this thing. I have no idea why, but it's good stuff. So what it actually does, you read in data, analysis, boring. As I said, it's exactly the model that I did in the slides. And then you get results, and then eventually you see all the code at the end where this is a little bit boilerplate code, so you don't have to do this because I did it for you, and then you export the model. You have the saved model, it runs here. So I'm showing this to show you it's real stuff, so you can just use it if you want to. With that, I would like to close, but I have to go back to the slides here. So try this. I will post the link to it on Twitter in a minute or so. And with that, you can use pre-built ML services, and you don't have to understand how they work at all. So use them. They may not be perfect, but you just use them, and they can potentially do magic for you. If they are not good enough, you can train with standard free software, and it takes a little bit, like the process isn't easy to get, but the software is free, and you get a lot of resources. So you can do that. If you have customer data, you can do that. You can publish the trained model. You can't publish the customer data because of data protection law, but it's possible. And then if you do that, you can, depending on what you trained, you can deploy it on all major services. but it may depend which models you can deploy on which clouds. And this is exactly 0 seconds, so that's perfect. With that, thanks a lot. Try it out. I will post a link.